Hello friends, welcome back to Aliya Gupta. Today I am here to discuss the topics spherical mirrors. In the previous video, we discussed about plane mirrors. So here I have a plane mirror. It has a plane and flat reflecting surface. Now let's put it back and come to today's topic. Now, spherical mirrors are the mirrors whose reflecting surface is spherical. We call them spherical mirrors because they are part of hollow glass mirror. Now, it is of two types, concave and convex. Now, the reflecting surface of concave mirror is bulged inwards. Okay. And the reflecting surface of convex mirror is bulged outwards. So I have a convex mirror here. This is the convex mirror. You can see this. Now let's make this topic more interesting by taking out mirrors from hollow glass spheres. If we suppose that we have these two hollow glass spheres first, and this is the second one we have. Then we cut this from here and we cut this from here. Then we polish it to make it opaque. Here is the polish for concave mirror and here is the polish for convex mirror. This is the polish for convex mirror. Now, how concave mirrors are made? We take out this piece like this. Then we polish it. So we get a mirror to make it opaque. Okay. Now the mirror formed is like this. We get a mirror. Now let's come to convex. Now this is the piece we have taken. If this is the piece we have taken out, then we shade this portion. No, we don't shade this portion. We shade this portion and we get this polished surface. We polish the surface, so we get a mirror like this. Now let's understand certain terms for spherical mirrors. Our first term is center of curvature. You can see these hollow glass spheres. The center of these hollow glass spheres, this and this, these are called the center of curvatures. It is noted by capital C. Actually, center of curvature is not a part of mirror. It lies outside the mirror. It is the center of the hollow glass sphere and it is noted by capital letter C. Now, our next term is pole. Now, pole is the center of the reflecting surface. Here is the pole. It is denoted by capital letter P. Now, the radius of curvature. The radius of curvature is the line joining the center of curvature to the pole. Here. So, this is the radius of curvature. It is denoted by capital R. This is denoted by capital R. Now, here the radius of curvature is this. This is the radius of curvature. Now, if we notice that this radius of curvature is the radius of the hollow glass sphere and it is denoted by capital letter R. Now, our next term is principal focus. Now, principal focus is called principal focus because it lies on the principal axis. Now first let's define principal axis. Principal axis is a line passing from the center of curvature to the pole. So this is the principal axis, this one, and in convex mirror, this is the principal axis. This is the principal axis in both the mirrors. Now, principal focus. Principal focus is called principal focus because it lies on the principal axis, and the rays meet or appear to meet after reflection by a mirror or refraction through a lens at this point. Now let's understand this with the help of an example. In a concave mirror, if this is the mirror, big, this is the mirror surface. Now this is the pole, this is the principal axis. So this is a parallel beam of light. So it meets here at this point. So this is the principal focus. This way and this way, this way and this way. And it retraces its path. Now let's take the example of convex mirror. Like this, it is the mirror. So this is the principal axis, this is the pole. So this is a parallel beam of light. This retraces its path and it goes like this. But if we extend these two rays backwards, so this is the principal focus. So principal focus of a concave mirror is in front of the mirror, and the principal focus of a convex mirror is behind the mirror. So that was about principal focus. Now let's define aperture. Aperture is the diameter of this reflecting surface of this mirror. It is the portion where reflection of light actually takes place. Here, this is the aperture, this one, and here, this is the aperture. Now, there's a now the last term here. Also, principal focus is the midpoint of radius of curvature. So for this concave mirror, this would be the principal focus, and for this convex mirror, this would be the principal focus. Now, a term focal length. Focal length is the distance between the pole and the principal focus. Here, this is the focal length. This, and here, this is the focal length. So this one is focal length for this concave mirror, and this one is the focal length for this convex mirror. Now, there is a relation between the radius of curvature and the focal length. As we have seen that the focal length is the midpoint of the radius of curvature. So the focal length equal to radius of curvature upon 2, or we can say that radius of curvature equal to 2 times the focal length. So that was all about spherical mirrors. So thanks for watching. Keep liking, keep subscribing and keep suggesting. Thanks and bye bye.